Now with the y equals cosine of x. Here is our cosine function. Our a will help us to identify if there's a reflection, and the absolute value of a gives us our amplitude. The b, the multiplier in front of the x, to find the period how long a revolution occurs, you take 2 pi over b. The plus d is you're moving up or down. So if you have a positive d, you move up. If you have a negative d, you move down. If there is a negative a, we're going to reflect it. So instead of at the top of the amplitude, you would start at the bottom of the amplitude. All right, so let's do an example. Refer to cosine function, remember, it looks like this. Parent function, period is 2 pi, amplitude is 1. All real numbers for the domain, and then the range is -1 to 1. Here's our first example. I'm going to just go ahead and rewrite this as y equals negative cosine of 1/4 x. I think it looks sometimes confusing when books go x over 4. So I'm just splitting that up into 1/4 x. Now we take and talk about the a. The a value is -1. So that means, yes, there's a reflection going on. The amplitude is the absolute value of a, so that's 1. The b value is the multiplier in front of the x, which is 1/4. So to find the period, we take 2 pi over b. So we substitute b in, 2 pi over 1/4. And what we have here is a fraction over fraction. So I'm going to keep the 2 pi, I'm going to change it to multiplication, and then I'm going to flip the 1/4 as 4 over 1. And now I multiply across. 2 times 4 is 8 pi. So now it takes 8 pi for one revolution to occur. Takes longer. So I don't have any shifts up or down, so I'm good with that. My amplitude was 1, so I'm up 1, 0, and then down 1. My period is 2 pi, so I start at 0, and I'm going to finish at 8 pi. Now I split that 0 to 8 pi up into 4 equal parts. So halfway is 4 pi, halfway again is 2 pi, halfway again from 4 pi to 8 pi is 6 pi. Now I have my 4 equal parts. Now there was a reflection going on. So normally we would start here with the cosine, but I'm going to erase that. I have to start at the bottom of the amplitude. So I'm going to start down here at -1. And now I do my pattern. Middle, top, middle, and bottom. And there is one revolution for this graph. If we wanted to continue, we would just continue adding another 8 pi, split up into 4 equal parts, and continue that same pattern. Let's do a second example, a little bit more challenging. So here's our a value. So our a value is 1/3. So that means our amplitude is absolute value of 1/3, which is just 1/3. Our b value is pi. Haven't seen that yet, that you have a not just a number. So to find my period, I go 2 pi over b. 2 pi over pi. What happens is those pi's cancel out and we're left with 2. So my period is 2 radians. And then the last thing I notice is I have a -2. So what this does is it shifts everything down 2 units. So yes, there's a translation. We're going to shift down 2. So if I have my horizontal axes normally right here, I'm going to shift my horizontal axes down 2 units. So theirs will be my middle. So here is at -1 and then -2. Now I do my amplitude. My amplitude is up 1/3 on that horizontal axis. So up 1/3 and down 1/3. So it's going to be really scrunched up. So this would be like -1 and 2/3, and this would be like -2 and 1/3. Now I find my period. My period is 2 radians. So I start at 0, I'm just going back to the axes, and I finish it at 2 radians. Halfway between 0 radians and 2 radians is 1 radian. Halfway between 0 and 1 radian is 0.5 radians, or half of a radian. And then halfway between 1 and 2 radians is 1.5 radians. All right, now we're set to go ahead and graph this cosine function. So the cosine function starts at the top of the amplitude. So right here is the top. It goes to the middle, goes to the bottom of the amplitude, back to the middle, and then back to the top. So it's really small, very scrunched together. And that's the graph.